Thanks for the opportunity to present the Guyana-Suriname Deepwater Hydrocarbon System, a story of 3 rivers and 2 source rocks. My co-authors are Masab Nasser and Dick and John Boyce. We all work for JHI, and I appreciate the opportunity to work on this data and to present the story to you today. The 3 river systems are the Demerara, the Berbice, and the Amazon, and the source rocks are the Lower Albian and the Turonian Canje. The story starts with the Lower Albian source rock being deposited in the deep water, surrounded by the Neocomian carbonates and the Demerara clastics on the east side. The second part of the story is the massive Berbice river system dumps a tremendous amount of sediment into the basin from a canyon system and matures the OAE1 source rock. It also provides excellent quality deepwater reservoirs in the Campanian, Maastrichtian, and Santonian. And the third part of the story is the Amazon. The Amazon river system moves north of the equator in about 10 million years ago, and shelf currents drive that Amazon sediments to the north into the Guyana Basin. This overburden matures the OAE2 source, in fact may push it into the gas window at the prograding edge, and it also preserves the reservoirs at a very significant depth below mudline, but preserves reservoirs with good porosity and permeability for AVO, flat events, and down-dip conformance, and also puts these reservoirs in water depths that current technology can develop. This slide shows the 3 river systems that we'll be talking about today. First of all, the Aptian Demerara river system drains parts of Africa and South America as these 2 continents were splitting apart, and it dumps a tremendous amount of clastic sediment in eastern Suriname. The second river system is the Berbice, which was draining a huge part of the northern part of South America, larger than the Orinoco and maybe even as large as the Amazon. It drained into the Guyana-Suriname basin through the Takatu Graben and a 1,000 meter deep shelf canyon, providing a point source for a tremendous load of sediment out in the Guyana basin. And the third river system is the Amazon. About 10 million years ago, the mouth of the Amazon moves north of the equator, and very strong equatorial currents, shelf currents, move that sediment to the north and deposit it in the Guyana basin. We know this because Exxon has published that there are Devonian second cycle polymorphs in Miocene age sediments of the Amazon, Fossa Amazon wells, and also the Guyana basin wells. Since there's no Devonian outcrop anywhere in the current river systems into the Guyana basin, that must have come from the Devonian outcrop along the Amazon. This cross-section is an east-west cross-section across the Guyana-Suriname deepwater basin here, going to the shelf on the western side and on the eastern side. You can see in blue the Neocomian Jurassic carbonate platform on both sides, the Demerara Clastic on the east side, and the OAE1 Lower Albian source rock. The OAE2 Turonian source rock is just above that shown here. The interval of Berbice sedimentation is shown in this green arrow from here to here, and that matures the Lower Albian source rock where this light green material shading is on top of it. The Amazon sediments, you can see, are quite thick in this area, and that matures the Turonian source rock where it is colored in this light purple color. For the next few slides, I'm going to show a paleogeography map along with an isochron from the 2D seismic data. This first map shows the Neocomian to Jurassic carbonate platform. It also shows the Demerara clastics here, as well as another Deltaic system that is currently over in Guinea in Africa. It also shows the Lower Albian deepwater source rock in this area. That paleogeography map is based on an isochron, the Albian down to the Neocomian, and this is that isochron, where that Aptian clastic system reaches up to 3 seconds of sediment in the deep water of Suriname. We've also shown over here a small section of the beginning of the Berbice sedimentation, which is the uppermost Albian in that area. Next map shows a paleogeography map of the Turonian and the Berbice Clastic system. So the Turonian source is a much more widespread source. And Bob Webster's paper at this conference documents a Turonian flood as far back as the Graben, the Takatu Graben back here to the south. This is the Berbice Canyon, the nearshore part of the Cretaceous, and the deep water sedimentation of the Berbice deep water system. This significant overburden starts maturing the OE1 source rock as early as the latest Cretaceous. This isochron shows the effect of the upper Cretaceous Berbice. It's an isochron from the top Cretaceous down to the Canje source. You can see just in that interval there's over a second worth of sediment and overburden in the area. This overburden, as I said, matures the lower Albian OE1 source rock as early as the top of the Cretaceous. The Amazon Deltaic system is shown here. The Amazon sediments are swept along the shelf by strong equatorial currents up into the Guyana Basin and develop a significant progradational wedge in the area labeled shelf here, and a significant amount of deeper water clastics out in the basin. There's significant mass transport complex associated with, and just a tremendous amount of sediment out in the Guyana Basin moving along the shelf from the Amazon. This is an isochron of the upper Miocene-Pliocene. It's from a 10 million year unconformity surface within the Miocene up to the seafloor, and you can see 2.5 seconds worth of sediment in this progradational wedge area here, as well as 1.5 to 2 seconds of sediment throughout the rest of the deepwater Guyana-Suriname basin. We would also suggest that the gas associated with some of the recent discoveries are from the maturity from this overburden. This overburden clearly pushes the Turonian Canje OE2 source rock into the oil window between 5 and 10 million years ago. This map shows the isochron from the seafloor down to the Canje source rock. We've done some basin modeling and estimate that the oil window is about 2.5 seconds below mudline, and the gas window is about 4 seconds below mudline. And based on this time below mudline, we can see that there looks like there'd be a gassy area here underneath that progradational shelf of the Miocene sediments, and an oil window out in most of the basin from at least 5 million years ago. But also show cross-section AA prime and BB prime, which I'll get to in a moment, which will show rates of sedimentation, which has a significant impact on the hydrocarbon generation in the basin. Next map shows a similar maturity map of 2.25 seconds below mudline and 3.6 seconds below mudline for the gas window for the pre-Amazon sediments on the lower Albian source rock. So this is the maturity of the lower Albian OAE1 source rock prior to the Amazon sediments. This maturity would onset at the top of the Cretaceous and be generating hydrocarbons for 40 or 50 million years. The next lines are the cross-sections. And a couple of things about the cross-sections is basically south to north, you see the Neocomian platform and the deep water, and the lower Albian OAE1 source rock, and the green area there shows where that lower OAE1 source rock, lower Albian OAE1 source rock is mature and present. The OE2 Turonian Canje source rock is shown there, and the purple shows where it would be mature based on the Amazon sediments. Another thing you can see on these sections is that it took the whole Berbice system 60 million years to develop this 2 seconds of sediment here, and it only took the Amazon about 10 million years to develop 2 seconds of sediment here. So the rate of sedimentation is drastically changed throughout the basin. And that's what I'm showing up here, is basically its time in milliseconds from the seismic data versus time in millions of years from the from the geologic age. So you can see high sedimentation rates of the carbonate, low sedimentation rates in the deeper basin, and when you get up into the Berbice section, you can see moderate sedimentation rates with some punctuations for the source rock. But when you get up into the lower tertiary section, the Berbice is captured, and there's very much a starvation of the deep water basin, and that's what allows this lower Albian source rock to be in the perfect oil window for 40 or 50 million years, generating hydrocarbons from this source, while this overburden is present and very little additional sediment is deposited. Then about 10 million years ago, this massive amount of Amazon sediment is introduced into the basin, which matures the OAE2 Turonian source rock. The same is true on this section. Again, from south to north, you can see the Neocomian carbonates, the OAE1 lower Albian source rock. In this case, in this side of the basin in Suriname, there's not enough Berbice sedimentation to mature the OAE1 source rock prior to the Amazon. You can see the Demerara clastics and the carbonates again in the Jurassic to Neocomian. The purple area here is where the OAE2 source rock would be mature based on the Miocene sediments. I've also shown on both of these cross sections a dashed blue line here, which is 2.5 seconds below mudline, to use as a proxy for where that source rock would be mature. Again, the same story. The rates of carbonate sedimentation are fairly high. The sedimentation in the deeper basin is low. The sedimentation rate in the Demerara clastics is massive, as these Africa and South America draining continental river system dumps clastic into the area. Again, very low sedimentation where the Berbice is not present. Moderate sedimentation here where the Berbice is present, and then again very, very low sedimentation rates out in the deepest water, but you can still see the influence of the Amazon sedimentation rate there. So again, the story is the same, is the deposition of the Berbice matures the lower Albian source rock in parts of the basin, not here, but in other parts of the basin, and the sediment from the Amazon matures the Turonian source rock late. The next few slides are a couple of 3D visualization tools of grids based on the 2D data. So to introduce these, first of all, north is to the lower part of the screen. So you're looking to the south. You're out over the Caribbean waters looking to the south continent of South America. The Neocomian carbonate platform is shown in a rim around the basin, and the deep water Aptian section and lower Albian section is shown here. There are several highs in the basin. The Ranger is a significant high here. There's an Aptian basalt here. There's a structure here, as well as some additional structures there. The next phase is the deposition of the lower Albian OAE1 source rock, confined by the Aptian clastic system here and the Neocomian carbonate system around the corner there. So that's the location of the lower Albian source rock. On top of the source rock, you get the Berbice deep water clastic system. You can see the deep water canyon, single canyon cut coming through here for the providing significant sediments to the deep water in this Berbice river system, and that provides the overburden to mature the OAE1 source rock. It's also the shape of the basin when the OAE2 Turonian source rock is deposited. So the next slide is the top of the Cretaceous. You can see the basin continuing to fill in. You can see the amount of overburden on the OAE1 source rock to allow it to mature, but there's not enough overburden on the OAE2 source rock for it to be mature at this time. The next slide shows the 10 million year Miocene surface, this significant unconformity mapped across the basin. It shows a couple things. First of all, there's very little sedimentation from the top of the Cretaceous in that 40 to 50 million year period between the top Cretaceous and Miocene. The OAE1 source rock is still mature, but the OAE2 source rock is not mature at this time. This also shows the location of a significant prograding wedge of the Miocene Pliocene right along the shelf, as well as very significant mass transport complexes and thick sedimentation out in the deep water part of the basin. The last surface here is the seafloor. You can see this tremendous amount of Miocene, 2.5 seconds of Miocene sediment here, and that's plenty of overburden to mature the OAE2 source rock, although it only occurs about 5 million years ago. You can see the high sedimentation rates in the Berbice section, the low sedimentation rates in the lower tertiary section, and the very high sedimentation rates in the Miocene section from the Amazon River system. So we'll conclude the talk with a detailed listing of the major geologic events that shape this hydrocarbon system. First of all, the Jurassic to Neocomian carbonate platform rims the basin. The Aptian Demerara clastics come in on the eastern side in central Suriname, and that sets up the deep water part for the lower Albian source rock. The source rock is deposited at a time with very low sedimentation in the basin. There's no clastics in the section. There's just a few carbonates on some very structural highs, but 1,000-meter deep holes into these anoxic environments where the source rock is deposited. The next stage is the Berbice. It starts in the very beginning of the uppermost Albian section with the Berbice sediments, and then grows into the Sedimanian, and finally in the Santonian, there's a 1,000-meter deep canyon cut across the shelf, and this provides a single point source of significant amount of sediment into the basin. This sediment provides excellent reservoirs in the Santonian, Campanian, and Maastrichtian. Then in the top of the Cretaceous, the Berbice is captured by a series of smaller drainage systems, and the sediment is stored up in the shelf and in these systems, so the deep water sedimentation is very low. This low sedimentation rate allows the overburden from the Berbice system to mature the OAE1 lower Albian source rocks for a very long time, although if the migration is occurring into shallow reservoirs, it could be biodegraded. On top of that, there's the Miocene shale that is a regional seal. Above that, there's a significant erosional unconformity at 30 million years in the Oligocene. This is a major drop in the sea level, which basically has a whole series of canyons cut in the shelf edge and provides a whole number of points for sediment entering the basin. And then finally, at 10 million years, the mouth of the Amazon is north of the equator. So you have equatorial northwesterly shelf currents driving tremendous amounts of sediment along the shelf, prograding out the shelf edge in the Guyana-Suriname basin and creating a significant mass transport complexes in the deep water. We also assign this gas generation from this significant shelf margin progradation, which overburden, which causes the OAE2 source rock to enter the maturity window over the basin and in some places into the gas window. Thank you very much for your attention, and again, I appreciate the opportunity from the AAPG and from JHI to make this presentation. Thank you.